In this video, we're going to talk about how to solve problems related to static equilibrium. I have set up here a little system. Let's say this is a hanging sign that's hanging by two cords. One is at a 45-degree angle, the other is at a 20-degree angle. I want to figure out what is the value of F1 and F2. I have two unknowns here. So I'm looking for F1, F2, both of them. What I know about this is that it's got a mass of 45 kilograms, so I can easily calculate the force of gravity. So let's put that up here. I also know that these are going to be at angles, so I can break them up into their individual components. So let's write out those components and the equations that would go with them. This will be F1, that'll be cosine of 45. And then Fx2 should be F2 cosine. Then we're going to use 20. We're going to use 160. We use this 160. Notice I'm using 160 as my angle here because this would be 180 minus 20. There we go. So I can put these together into two main points. My sum of all forces in x look like this. F of x1 plus f of x2. And this equilibrium, because this is in static equilibrium, that means this is going to be zero. It's not moving. So there's no net force on this. And so I can write that out, and then I can replace this x1 and x2 with their parent equations. And so f of x1 is going to be f1 times the cosine of 45. And f of x2 is going to be f2 times cosine of 160. Now, cosine of 45 and cosine of 160, those are just numbers. So let's punch those functions in and get the numbers that go with them so that we can make our lives a little bit easier later. Then let's move F2 over to the left side by adding 0.939 F2 to both sides. And then let's get F2 to be on its own by dividing both sides by 0.939. And when I do that, I find that F2 is going to be equal to 0.753 of whatever F1 is. This is going to be very important for later, so let's just identify that that is there, and then let's make another equation. We're going to be substituting our equations into each other. So now we need to do the same thing. I'm going to make a little space for myself here to keep my stuff differentiated. Let's do the same thing for the y. Now I know all of this has to even out to 0 because it's not moving. And then let's replace our f1y and our f2y with their parent functions. This will be f1 sine 45, and f2 will be f2 sine 160. And then it'll be plus fg. Now let's convert these signs into actual numbers, and let's calculate what our fg is going to be. Remember, our mass here was 45 kilograms. So it's going to be 45 times 9.8. And my force of gravity should be a negative number because it's pointing in the opposite directions of my two forces. And now we're ready to rock. So let's go ahead and take this equation right here, which has F2 equaling something of F1, and let's plug it in for F2. So I'm going to get 0 equals 0.707 F1 plus 0.342 times 0.753 F1 plus negative 441. Now I'm going to add 441 to both sides. And I'm going to distribute this 0.342 into the 0.753. Just multiplying decimals here. And that gives me 0.258 8f1. And now these are the same variable, that one, that one. So I can just add these together. And I get 441 equals 0.965 f1. And then I can solve for f1 by dividing both sides by 0.965. And I end up with 457 for my f1. That's my first answer. I can now take this answer, this number, and plug it in for f1 in this equation and solve for f2. And so when I take 0.753 times 457, I get 344. And so now I have found the value of both f1 and f2. And we were able to do that by creating two individual equations. One that was my equilibrium of forces in x, and one that was my equilibrium of forces in y. And when I do that, I can then take one equation and substitute it in for the other one in order to solve for both of these unknowns. Let's try one more problem like this. In this problem, I've already got my variables listed out, and I've given them different colors to make it a little easier to follow along with which variable is where. For instance, x1 and y1, both are already set up to have f1 replaced in. And then I've got my force of gravity, which I can determine immediately by taking 100 times 9.8, which is going to give me 980 newtons. So what I want to do now is I want to go ahead and put together my two equilibriums. I'm going to have an equilibrium of my forces in x, which is going to be equal to force of x1 plus the force of x2. And immediately I'm going to say that that's 0, and I'm going to replace these two with their parent functions. Following that, I'm going to get these two cosines into their actual numbers, and then I'm going to solve for one of these variables. It really doesn't matter which variable I decide to solve for. I usually just solve for f2 so that I end up finding f1 first. All right, I've got my conversion that in x is giving me f2 equals 5 times f1. That's going to be a pretty big number then. So let's go ahead and do the same thing for my variables in y. Then I'm going to move my 980 over to my left side, and I'm going to get numbers for sine 30 and sine 100. Next, I'm going to take my 5f1 and I'm going to substitute that in for my f2. Then I'm going to distribute my 0.985. And finally, I'm going to add my two f1 variables together. I'm going to divide both sides by that product, by that sum. Now I've got 180.6 for f1, and I can plug that in right here. And I end up with 180.6 for f1 and 903 for f2. So if I have a situation where I have two missing variables, I can always use substitution if I can create two distinct equations.